Okay, we're doing number 7. And it says, part A, first of all, we're given that y equals sine of x and y equals cosine of x. And it says, A, where do they intersect? And that's going to be at pi over 4 because sine of pi over 4 and cosine of pi over 4 is square root of 2 over 2. So this point is pi over 4 square root of 2 over 2. And it says, what's the first positive x value where they intersect? And that's at 4, pi over 4. Set up a definite integral whose finds the exact area bounded by this, and the y-axis. So that's this area. So that would be b, the integral of the top one minus the bottom one from 0 to pi over 4 dx. Antiderivative of cosine is sine. Antiderivative of sine is negative cosine, so that turns into positive cosine x, evaluated from 0 to pi over 4. Put pi over 4 in, you get square root of 2 over 2 plus another square root of 2 over 2, minus putting in 0, sine of 0 is 0, cosine of 0 is 1. So we get square root of 2 minus 1. We did that problem earlier when we were first doing these areas between curves. Now C says revolve this around the x-axis. So then it would be, and around the x-axis. So we can do disc or washer, there'll be a hole in it, so I'm going to do that. So the thickness is dx, it's in the x direction. So integral of pi large radius, that's all the way up to the curve here, that's y value on this curve, which is cosine x, minus the small radius is up to the sine curve, so that's the y value, or sine of x. And the thickness was dx. And we're going to do this from 0 to pi over 4, which they allowed me to use the calculator technology, so it's going to be cosine squared minus sine squared. Cosine of x squared minus sine x, close parentheses, squared. Second, calculate 7, and I didn't put in the pi, so I'm going to go from 0 to pi divided by 4, and I get 1/2 times pi. 0.5, 1/2. Okay. D. Set up the definite integral whose back value of the following: the solid rotated around the y-axis. So now we're going to take this around the y-axis, which would be something like this. And this would be easier to do with the ring. If I do discs, I'm going to have to do from here to there, and then from there to there. So I'm going to do ring method on this, which is 2 pi integral from, let's see, the ring is going to be a slice this way. It's still going to be dx, and the radius is going to be out x, and the height is going to be the difference in these, which is the cosine is the highest minus the height of the lower one, which is the sine of x. And I'm going to go from 0 to pi over 4. So it's going to be x parenthesis cosine x minus sine x and times 2 pi. I'll get the 2 pi right in there. Well, let's leave the pi out. Let's see. So calculate 7 and from 0 to pi divided by 4. That's that little bit, which is 0.22144. 0.22144415 pi, and I don't recognize that number, so I'll just go second quit. 0.22144415 pi, and I'm getting a value of 0.6956. Okay, that's dE of the solid revolved around y equals 2. Y equals 2 is up here, so this shape, so E, let's do this one over. So we've got this shape, and this is 1, 2 is here, so it'd be 3, and this would go this way, and then from here this would go from this way, and this is pi over 4. So this is round y equals 2. So let's do a disk method, because ring I would have to do with this curve, and then I'd have to do with this curve. So I'm going to do a disk method. So the thickness is dx pi large radius squared minus a small radius squared dx integrated from 0 to pi over 4. Large radius is going to be, well, it's going to be from here to there, which is 2, this is 2, minus this, which is the sine of, it's the y value here, which is the sine of x. And I want it in terms of x, so it's 2 minus sine x squared minus the inside radius is 2 minus the y value for the other curve, which is cosine. dx. So on y equals, let's just clear it, parenthesis 2 minus sine x, close parenthesis, squared minus parenthesis 2 minus cosine x, close parenthesis, squared, and I'm going to go parenthesis, and I have to go back and put the parenthesis at the beginning of this, and all this is times pi. Second, calculate 7 and we're doing this between 0 and pi over 4. 0, enter, pi divided by 4, enter. 3.634. Approximately. And F. They're gruesome here. definite integral whose value is the exact volume of the solid going around the x equal minus 1. Okay, so the cosine curve, sine curve, pi over 4, 1, x equal minus 1. So we'd have this and this, and this would be easier with the ring. I would then do a slice this way, which should be dx, thick. It'd come over here. So 2 pi r, the radius, it's going around minus 1, so it's 1 plus x. That's the radius, because this is over x, and if it's around minus 1, this would be 1 plus x is the total radius, times the height, which is this curve, height up to that curve, minus the height up to that curve. D, thickness was dx, and I'm going to evaluate x from 0 to pi over 4. A lot easier than trying to do the discs, the washers for this part, and then change to the washers for this part. And let's work this one out. Clear 2 pi parenthesis 1 plus x, close parenthesis, parenthesis, cosine x, close the parenthesis on the cosine, minus sine x, close parenthesis, and close parenthesis. Second, calculate. 7, 0 to pi over 4. 0, enter, pi divided by 4, enter, and 3.298. Approximately 3.29825.